This video by Sahil Wankhede focuses on using OpenCV3 with Python 3 to understand contours in images. A contour is defined as a curve that connects continuous points along a boundary with the same color value. The video explains that images can have multiple contours, especially when containing multiple objects. By finding and drawing these contours, a segmented image can be created. Key OpenCV functions discussed include CV2 find contours, which detects contours, and CV2 draw contours, which draws them on an image. The video also touches on the importance of converting images from BGR to RGB and to grayscale, primarily because creating a binary image from a grayscale one makes it easier to identify contours due to the clear distinction between pixels. The output image after applying a threshold of 127 is presented with an indication that the threshold value can be adjusted. The provided text describes a process for image processing using OpenCV, specifically focusing on binary thresholding and contour detection. The workflow begins by applying a binary thresholding algorithm to an image to create an intermediate thresholder result. While the visual output may appear in color due to the absence of a grayscale map in the display settings, the data remains functional for subsequent steps. This thresholder image is then used as the primary input for the CV2.findContours function. This function requires additional parameters including retrieval modes and approximation modes, which define how contours are identified and stored. The function returns three key values: the original image, a list of contours, an array of 32 points representing the curves, and the hierarchy of those contours. Finally, the contours are visualized using the CV2 draw contours function. Since this function superimposes the contour patterns directly onto the image provided, the original image is reloaded into a separate variable to ensure both the raw and processed versions are available. The final output, showing the contours overlaid on the image, is then displayed using matplotlib. This text describes the process of fine-tuning contour detection for image segmentation using OpenCV. After executing the code, the original image is displayed alongside a version where contour curves are superimposed. The user specifies the contour appearance using parameters like 00255 for color, specifically choosing blue to contrast against the red and green tones of the image, and a width of 2. A critical part of the process is adjusting the binary threshold value to improve object distinction. Testing different thresholds shows varying results. Threshold 50 provides an excellent result for distinguishing individual objects. Threshold 25 leads to poorly defined boundaries. Threshold 75 produces a different segmentation style altogether. Ultimately, these contours serve as a powerful tool for image segmentation and defining object boundaries. This foundational technique